Okay, a body with mass 250 grams is attached to the end of a spring that is attached by a force of 9 newtons. At time t equal to 0, the body is pulled 1 meter to the right, stretching the spring, and set in motion with an initial velocity of 5 meters per second to the left. Find xt in the form of c times cosine of a single function. And b, find the amplitude and period of the motion of the body. Let's try this. I don't think there's anything about the damping. If there was damping, there should be dash pot or something like friction somewhere, so there's no damping at all. Therefore, it should be like in the mx double prime plus cx prime plus kx equals to f of t. This is the master equation with damping and spring constant and the mass and external force. What we have here is no external force. I don't see anywhere any mention of external force. I don't see any mention of the damping constant, so it must be just mx double prime plus kx equal to 0. Now, m is explicitly given. What's the value of m?
250.
250 grams. It should be in kilograms. So what is that?
0.25.
0.25 kilograms. Okay. So m should be taken as 0.25 because in the formula F equals to mg, MA, in the formula F equals to MA, m has to be in kilograms if A is to be in meters per square second, then F has to be in newtons. Okay? So if you want the newtons with meters and seconds, you need the m to be in kilograms. So m is 0.25. That's given in the question. However, I don't see anything about the k, spring constant k. So how can we figure that out? You see this force of 9 newtons, right? What did the 9 newton of force do? It stretched the spring by how much? 1 meter. Okay, so how can you relate that with the k?
Well, F equals negative k.
Right, force of the spring is negative kx. And really the external force is in balance. So see, the reason it's stretched at 1 meter and not moving at that point is because the force of the spring, which is that direction, right, is countering the force that you're stretching. So really the force of the spring is in the left, which means it's negative 9. K is unknown, but you know that it's pulled 1 meter. But if you don't want to think about the signs, that's fine. You know, you can just say F equals to Kx and just plug in 9 for the force and 1 for the length and find K that way. Okay? So anyways, that tells us that K is 9. It's really 9 newtons per meter. So every meter that you stretch, you will need 9 newtons. Okay. So plugging in the value of m and k gives you the following equation: 0.25 x double prime plus 9 times x equal to 0. And then you've stretched it, and now you're pushing it to one side, 5 meters per the left, 5 meters per second to the left, and it was set in motion initially at 1 meters on the right, right? Therefore, you can say that the initial position and the initial velocity is each what? Initial position is
0, 1,
1. It was 1 to the right, so it's 1. What's the initial velocity?
5 meters per second.
Negative 5, because 5 meters per second to the left. Right. Once you have everything with kilograms, meters, and seconds units, then you can forget about the units and just solve. Now let's solve this system. To solve this, you need first the characteristic equation, which is 0.25 r squared plus 9 equal to 0. And because this is 1/4, I'm just going to multiply by 4 to everything to get r squared plus 9 times 4 is 36, which you can solve it as square root of negative 36. That's 6 plus minus 6i, right? That means, what are the two solutions? XTR.
The 1.
No, I. Oh, there you go. E to the 0th power is 1. Yeah, so you do that. And then
Cosine.
cosine 6t C1 sine 6t C2. That's your function. And then we have to use the initial conditions to figure out the values of C1 and C2. Value of to get the value of C1, you plug in 0, and you realize that cosine 0 is 1, so you get C1, whereas sine 0 is 0, so you only get C1, and that should equal to the value 1. So C1 is 1. Now let's differentiate. X prime of t is negative 6 C1 sine 6t, and then positive 6 C2 cosine 6t. This time when you plug in 0, you get, it's supposed to be negative 5, but the only survivor on the right is 6C2. So when you solve this, you get C2 equal to negative 5/6. Therefore, you get the answer as x of t equal to, what do we have? C1 is 1, so it's 1 times cosine 6t, and then minus 5/6 sine 6t. You can say that this is the solution to the mechanical system described. However, part A says you need to write this in terms of c times cosine omega t minus alpha. That's the form it asks us to convert. And we had various formulas for this. First, how do you get the amplitude, which we call as c? Get it by square root of 1 squared, the coefficient of cosine 6t, plus negative 5/6 squared. And that's just 1, but since I'm going to get 36, let's put everything over as 36. So 1 is 36/36, and 5 is 25. 5 squared is 25, and then you have over 36, so you get the square root. And square root of 36 is 6, so you get 6 in the denominator, whereas on the top you get 61. So that's your C. And then your alpha is tangent inverse of b over a, right? So it's negative 5/6 over 1. But then you also need to figure out which quadrant this comma this is at. It's because because the x-coordinate is positive and y-coordinate is negative, you're at the fourth quadrant. If you're in the fourth quadrant, you have two options. You may just not add anything at all, or you can, if you want everything in between 0 to 2 pi, the thing that you have to add is 0, pi, pi, 2 pi. So if you're at the fourth quadrant, you want to add 2 pi to make everything, all the angles always fit between 0 to 2 pi. But here, this 2 pi is kind of optional. You may or may not want to. Let's just not do it. Let's just say tan inverse of a minus can be pulled out because tangent inverse is an odd function. For tangent inverse and sine inverse, you can pull the minus in front, whereas for cosine, that's not possible. And 5 over 6 divided by 1. Anything divided by 1 is itself, so I can just say tangent inverse of 5 over 6. And you can use a calculator to figure out what that value is. Let's try a calculator. 5 divided by 6 is 0.8333, and then if I do tangent inverse of it, I get 39.8 degrees. So this is about 40 degrees. That's the phase angle. But sometimes you can change the mode to radius. Let me see, how is oh, I know. Yeah, mode 5. Okay. And then let's do this again. 5 divided by 6. And then if I do tangent inverse, my calculator says in terms of radius, it's negative 0.6947. So let's just say 695. Okay. All right. Therefore, putting all these together, this thing, xt, can be written again as square root of 61 over 6 cosine 6t minus negative 0.695. I'm doing this because here we're assuming everything is in radians, so I should be using radians instead of the degrees. Okay, so from here, that's part A. Part A answer is this. Part B, what's the amplitude? What's the amplitude of this? That's the amplitude. And what's the period? So we know that when 6 is, if you didn't have a 6, cosine t has period of 2 pi. This just shifts the graph, so that doesn't do anything to the period, so it's still 2 pi. But if you have 6 times t, that shrinks the x direction by 6, so it will be 1/6 of the 2 pi, right? So the period, which often is written as t, is 2 pi divided by this, often called the angular frequency or angular speed. You divide it by the angular frequency, which is 6, and that gives you pi over 3 as your period. So amplitude is radical 61 over 6, period is pi over 3. That's how you solve this.